everybody. So today, uh, we will start our lesson probably around 5:30, 5:33-ish. So I'll put up a 3-minute timer. Hello everyone, and welcome back. Today we will be learning about lists and loops. So loops will include both the for loop and the while loop, which we will learn later on in the class. But first, we will elaborate on lists, which is one of the more common things that a loop will iterate upon. So here, I guess we'll get started on lists. So so lists is a collection, and a collection, in English terms, I guess, is a combination of data elements. And so, how does the program do it? Well, it will essentially dedicate um, consecutive memory spaces, and that is how the data is stored in a list.
So there's many types of lists. First there's like the normal list, where it's just like it's okay. So it can be you can have strings, um, integers and integers in it. You can and then there are you can add things to it and then remove things from it using these commands. Like append is add, remove is obviously remove, and then yeah, there's a lot of different kinds of functions on lists. So that's the basic type. Um, the next thing is oh, also you can show lists like where like a specific point on a list. Like let's say you have three things in a list, you can say print this list bracket two. That would be like the third point, because this count from 0 to 0. They start from 0, so the first item in a list is also known as number 0, and then so on. So if you say print this list bracket 0, it will be the first thing for the list.
So this is known as an index in a list, and indexes is very useful. So typically, as a programmer, whenever you define a list, you want to make sure you keep track of the indexes, and typically when so since the list will start at index 0, that means that the last item in the list is not actually the uh, the size of the list, but the size of the list minus 1. Now this over here is negative indexing. So -1 refers to the last item in the list, -2 the second to last. Um, so this is special to Python. In other languages, it will return a null error, or essentially the code will not run because there is no such index as -1. But since Python has a special um, kind of processing unit or compiler for you, it will recognize that you're trying to access the last index or something like that, and it will return that last index for you. Now, a range of indexes is essentially it will return a list of all of the values between the two indexes. So this is it will not include the beginning index, but it will include the end index. So over here we can see 2 and 5 between indexes 2 and 5. So it will include um, at this third position all the way to the fifth position, which is over here. So here are a couple of examples that will show kind of uh, how a list works. It's a fairly simple data structure, and if we can go back here, there's only a couple of functions that you can actually complete. So we went over append and remove, and uh, most of these commands you see over here, you won't actually need to know. So the most common commands you will use are obviously going to be append and remove. There is also list.index, or return kind of like the index or something that's between the start index and the ending index. There is counting, so you want to count how many times a certain item appears in your list. There's sorting, and so sorting is very important. We will learn later on the different types of searches, if we can get to that. And so sorting is very important for a certain type of search known as binary search. And there's reverse and there's copy. These are used to kind of manipulate your list in a way. Copying would allow you to like play around with your list and like kind of change the values, and you will still have a copy of it. So over here we can see that there's using lists as stacks and well, using lists as queues. So stacks and queues is a pretty advanced topic. So I'm just gonna kind of explain it in a simple terms. So essentially, a stack is like you're kind of trying to like stack cafeteria trays. So when you stack the cafeteria trays, the last one that you put in is the first one that you will take out, because it only makes sense to take out the tray from the top and put the trays on from the top as well, because you wouldn't try to put the trays at the bottom or take them out of the bottom. So that is the data structure called stack. And so the only the way you can add and remove is um, in Python there's append and there is pop. So append is going to be your add, and pop is going to be your remove. Now you'll notice that there is no need for any index in here, or the number or the position where you're going to insert the number, because it is automatically set to the first index. I mean, the last index. And so that is essentially how a stack will work. And the list can, in Python, can easily implement that because it already has the pop method written in for you. Now, using lists as queues. So a queue is essentially a line. So you will queue for like buying a movie ticket or buying something at a restaurant, well, fast food restaurant at least. And essentially, when you wait in a line, you will enter in from the end of the line. But when you leave the line and you go order and you receive your food, then you will leave from the front of the line. So this is how a queue will work. And essentially, a queue will add at the queue will add at the very bottom of the line of the list, which is going to be over here. And then after it adds it and you want to leave, it will use a command called pop left. Now, this is in correspondence kind of to pop over here. So basically what it does, it will remove from the opposite end that pop does. So this will enable it to kind of uh, act like a queue. And so those are kind of very simple implementations of a list that we can see in Python. Now, it's easy to show how stacks and queues work using a Python list, because the methods are already written into the list itself. So there's no need to write your own implementation or import it from somewhere else. And we probably will not get too much deeper into stacks and queues, as these can be quite complicated data structures if we were to look farther into them. But this is kind of our brief overview of how a list will work. So um, the reason why we need to learn a list in the first place is because a list is very, very essential for storing your data. Now, storing your data in like multiple variables is fine when you have, say, 5 variables. But if you were to implement like a larger project where you need more than just 5, perhaps you need 500 variables or 500 slots to store your data, you wouldn't want to create to do that for you. Instead, you could just create a list, and you can just remember the index inside the list. Now, although this seems kind of repetitive in that you still need to remember the index in the list, it is much easier to access your data through the list and organize your data in the list, because it will automatically append it to the right place where you want it to append, and you will be able to remove at the right index, getting the value much more easily than if you're trying to remember all of the 500 different variable names and what they are meant to store. So now that we've learned why we want to learn about lists, what they can do, now we need to learn how to traverse a list, or essentially go through each of the values in a list. And so the way we will do that is something known as iteration. So iteration is essentially just going through each element in the list and checking each one of them for any condition. It can be if they are equal to a certain value, greater to a value, follow certain requirements that you give. And so essentially, uh, by traversing through the list, we can take out similar data and do it for whatever purpose you want. So there are two main types of loops in Python and pretty much in all programming languages, and they are the for and while loops.
So the while loop is a simple loop where it takes a Boolean condition, which we learned in primitive data types. So in that example there, when I is less than 6, it will do the actions in the loop body. So I starts at 1. So it checks the condition first before it executes the body. And if the condition is false, it'll skip the entire loop. And it will run so that program will add 1 to I every time it runs the loop. Once the condition is false, meaning I is equal to 6 or greater, it will become false and the loop will stop repeating. So you can use this to traverse the entire length of an array if you want, or just check conditions. You can alternatively pass the keyword true, like while true, and that will create a never ending loop unless you exit it. And you have two other statements, break and continue. So break, whenever the program hits the keyword break in a loop, for in that example, when it says if I is equal to 3, break, that means whenever I hits 3, it will leave the loop. So it will skip every iteration that would have followed. Continue means it skips the rest of the current loop it's on. So print I is after continue, and it once continue is hit, it will skip the print I. So you won't see the program print on that iteration of a loop, but it will move on to the next one and continue the rest of the program. You also have the else statement, which you can use to run the code when the while loop is no longer true, meaning that I is not less than 6. And once that happens, in that example, it will print I is no longer less than 6. So it's relatively similar to an if else statement.
So now that we've learned kind of how the for loop works, um, we can go through one of these exercises over here. So over here we can see that all we need to do is put while over here, and after we put while, it will essentially iterate through each one of the values inside this loop. So now that we've gone through one of the loops, we can go through the other type of the loop. And so the other type of loop is known as a for loop.
The for loop basically just reiterates values within a certain boundary. So in the first example, you can see that it says for prime in primes print prime, and it just prints out all the values in the list starting from the first value.
Okay, so in the next example, it's a little bit more complex. And it uses the range function. So this is an important function when talking about lists. So range 5 means the numbers from 0 all the way up to 5, but not including 5. So in the first part, it basically says for every number in range 5, which is 0, 1, 2, 3, and 4, it will print it out. In the next part, it's the same thing as before, but it's range 3, 6. So this means all the numbers from 3 to 6, but not including 6. So it will print out 3, 4, and 5. So in the last part, it's range 3 to 8. This means all the numbers from 3 to 8, but not including 8. However, there's a comma 2 in the range at the end. So this means it will go up by increments of 2 in the range of 3 to 8. So range 3 to 8 means 3, 4, 5, 6, and 7. But when it goes up by increments of 2, it will be 3, 5, and 7. And that's what will be printed out when you run it, as shown here. So now let's do a while loop example. It says count equals 0, while count is less than 5, print count, count plus equals 1. So count equals 0 means it starts at 0. While count is less than 5, print count means whenever count or a number is less than 5, it will print it out. Count plus 1 basically means add 1 to the previous number. For example, when we use 0, 0 is less than 5, so it will print out 0. And then it will add 1 to 0, then you'll test 1. So as we see here in the example, it goes all the way up to 4, because when 5 is introduced, 5 is not less than 5, so it won't print it out. It's equal to 5.
Here is another example of a break and continue statement, and over here we can see how the break statement will work. So essentially it will iterate, so since this is a while true, it will forever iterate, and as it iterates it will print the count, which is defined up here, and so it will continue going until it is greater than or equal to 5.
In the next example, where it says for x is in range of 10, if it will print all the odd numbers, because is if the remainder, if x divided by 2, if x is even, then it will continue and it won't print x, and it will go back to the beginning of the loop.
Okay, so in the next example, it says when count is equal to 0, while count is less than 5, print count, and then count plus 1. So it's basically like the example I did earlier. So whenever a count is less than 5, it will print it out, and then it will keep adding until 5. So, and then there's an else statement here. So when it's not less than 5, it will print out this statement here in the quotes. So in the next part, it says for I in range 1 through 10, which is all the numbers up through 10, but not including 10, it will test the if statement. And if it's true, it will break. I mean, it won't. If it's false, it will break. And then it will print I. And then if not, it will print this is not printed and all the other stuff in the quote.
Here we have another page on the for loop, and so as you can see, they share some of the same methods as the while loop.
So in this example, it has a fruits list with an apple, banana, and cherry, and it would print all of those fruits. And you can also print each letter within the string. So where it says in banana, it will print X, and it will print each letter.
How the next example will look. So essentially, what it's doing, it's iterating through each of the characters. So this is the break statement, and just as before, it will essentially break from the loop. So we can see these two examples. So here we can see it will iterate until it hits banana, where then it will break from the loop, and so it does not print cherry. And over here, we can see that there is a slight difference in the program where the print, instead of moving from before the if to after the if. And so only Apple will print because it detects banana, and it does not print because it has already broken from the loop. And the continue statement, which we also saw before, it will essentially continue if, but ignore this line. If it sees banana, so what it will print is apple and then cherry. And so finally, we can see something slightly different than we saw in the for loop. So, in the while loop, sorry. So, essentially, it just iterates from the starting index of 0 and increments up by 1 all the way up until 6, as we see here. And we have to make sure we remember that although it says up to 6, it does not actually include 6. And in range can obviously use a starting and ending index. As we can see over here, we can start at 2 and end at 6. So it will not print 6 again. And so over here, there's 3 parameters that were given: the beginning, the end, and its increment. And so instead of going up by 1 each time, it'll go up by 3. So instead of going from 2 to 3, it'll go from 2 to 5. And finally is the else. So the else is essentially the same as we saw in the while loop. And it'll print it if once it's done. And so this is a little different. It's a nested loop. So a nested loop is essentially a loop. So this will come into something known as time complexity. We won't get into detail about that, but the more nested loops you have, the longer time it will take for your computer to calculate it all. And you want to have as little nested loops as possible because it will take more time for your computer to calculate it if you have more nested loops. Over here, if we can see, so for X in and adjective, I guess, and for Y in fruits, then it will show each one of them in each possible combination. So it'll show red apple, red banana, red cherry, big apple, big banana, big cherry. As we see over here. Okay. So next is the pass statement. So pass is essentially when there's an error, you don't want it to show up on your screen because sometimes you can kind of predict an error, and sometimes there is nothing you can quite do when you're trying to get all the combinations, but you know that there's one case that will give you an error, and you don't want that one case to disrupt your program. So what you will do is you will write pass 0 and a maximum of 1. However, you ask it to increment by 2, which means that it will never increment through this loop. So there's nothing over here. And so finally is this exercise over here. It's fairly simple. You guys can try it out for yourselves. Does anyone have any questions at all? Alright, so if you guys don't have any questions, you guys want me to show the answer to it? Yeah, I'll show the answer. So that is going to be the answer to your for loop. Alright, so that will conclude class for today. So I guess see you guys next week. Thank you for listening.